Hello everyone. Let's just begin today's class with a quote that your success is dependent on your dedication. How much you dedicate yourself is how much you're going to achieve. So without wasting any time further, let's start with chapter acids, bases and salt. Okay, the things which we deal in daily life are classified under the compounds. Such compounds, they can be acids, bases or salts. For example, like citric acid in lemon, it is an example of acid. Ammonium hydroxide, sodium hydroxide, or soap, they comes under the category of bases. Salts, like common salt, sodium bicarbonate, copper sulfate, bleaching powder, they all comes under the category of salts. Now, let's just start with the topic indicators. What is indicator? Indicators are the substance which indicates the acidic or basic nature of a solution by changing its color. They just change their color and indicate whether the given substance is an acid or a base. There are three types of indicator. First is natural, second is synthetic, and third is olfactory. So the first is natural indicator. Natural indicator, as the name suggests, they are obtained from natural sources. For example, litmus paper, turmeric, and red cabbage. Litmus is of utmost importance. You will find the red litmus paper, blue litmus paper solution in the form of a paper also in the laboratory. Okay, the litmus is obtained from lichens. It is of two color, one is blue and the other is red. An acid turns blue litmus into red and red litmus into blue. Okay, so what will be the effect of base on a blue litmus? The blue litmus remain unaffected. Now let's just move to the second, that is turmeric. This can You can also do this at your home now. Take a turmeric powder, make a solution and carry out the reaction with base. Take any base. Okay. Now the third is red cabbage. The juice of red cabbage is originally purple in color. Juice of red cabbage turns reddish with acid and turns greenish with base. Okay. Now synthetic indicator. Synthetic, which are synthesized in laboratory. They are methyl orange, phenolphthalein. Phenolphthalein is of very much importance. Phenolphthalein, it shows pink color in the basic solution and remains colorless with the solid. Okay. Now next is methyl orange. Methyl orange is originally orange in color. It turns into red with acid and turns into yellow with base. The third category is olfactory indicator. Olfactory is related to smell. So there are substances which changes their smell when mixed with acid or bases. They are known as olfactory indicators. Now you can see there is a table: red litmus, original red, effect of acid no change, effect of base blue in color. I've drawn this table so you can just see I have mentioned all the indicators with their original color, what's the effect in the acidic medium, effect in the basic medium. Okay. Now the next is universal indicator. Universal indicator is a mixture of many different indicators or dyes which give different colors at different pH values of the entire pH scale. Now the pH is potential of hydrogen. pH is potential of hydrogen. What is this pH? Potential of hydrogen. We measure the concentration of hydrogen ions by the help of pH. Okay. So it is a scale ranging from 0 to 14. It is a value from 0 to 14. See, you will find the red color, then orange, then yellow, then light yellow, then greenish shade. And at 7, you will find the green color. Then the color shifts to blue. Red to blue shift. So neutral substance have a pH of 7. Acids have a pH of less than 7. And bases have a pH of more than 7. We will discuss into more details about the strong acid, strong base, weak acid and weak base when we will discuss about the classification. Okay, so let's start with acids. What are acids? Acids are defined as a compounds which contains one or more hydrogen atoms, Okay, now you know HCl, hydrogen chloride, hydrochloric acid. Now what happens to hydrochloric acid is when you take HCl, it will dissociate into H plus and Cl minus. But this H plus ion is not furnished till you mix water. So acids are the substance which produce hydronium ion on reaction with water. This hydronium ion can exist independently in solution. Now we will move to classification of acids. In the classification of acids, what we will find is classification is based on the source, on from what source we are obtaining the acids. It can be organic or it can be inorganic. Organic means which are derived from plants and animals. Generally, I can say that they are weak acids. Like if you take lemon, if you place the lemon juice on your hand, it will cause no harm. That is weak. In the next classification, we will learn what is weak and strong. So the second is inorganic acids or mineral acids. They are quite reactive in nature and they are obtained from the minerals present in earth. These mineral acids are strong in nature. They are strong in nature. Now, the second classification is on the basis of strength. That is strong and weak. Strong acids gives a large number of H plus ions. That is, they dissociate completely. They dissociate completely to give H plus ions. But weak acids, they do not dissociate completely. They are partially dissociated. So they will furnish less number of hydrogen ions. Now, third classification, on the basis of water content. What is the water content? So, dilute acid and concentrated acid. Dilute acid is the acid that has more amount of water, and concentrated acid is the acid which has less amount of water in it and more amount of acid content. Let us assume two beakers having the same capacity of 100 ml. I'm taking in one beaker, beaker A, say 50 ml of acid and 50 ml of water. In the beaker B, 30 ml of acid and 70 ml of water. So both will now have a capacity of 100. Now, in both the beakers, in first beaker, the amount of acid is 50 and in the second it is 30. So in the first beaker, the amount of acid is more. So beaker A is concentrated acid. Beaker A is concentrated acid. Now we will move to, before moving to the properties of acids, first let's just see, this is a very important thing. Generally what we assume that if we have to make a solution, we can take any of the component and mix with each other in any manner. But that doesn't goes good when we consider about acids, dilution of acid. What is dilution of acid? That is the addition of water. We don't add water to acid. Okay, acid is added to water. Why so? Because when water is added to concentrated acid, heat is released. Heat is released. This is a highly exothermic reaction. The steam comes out, which will lead to the spill of acid, and it can cause harm to your body. So always add concentrated acid to water. Remember, always add concentrated acid to water. If you have to carry out a dilution, what you will do, you will take water in a beaker and pour acid into the water. Okay, so I'm leaving you till this topic today. In the next class, we will move further into the properties of acids. Thank you.